students, in this video we are going to see problems for 5 marks on convolution theorem. Yes, first question I have taken. What is given? You are given f of t and g of t, two functions, and we have to find out Laplace transform of this. Laplace of f of t star g of t is equal to Laplace of f plus Laplace of g. This is what is the convolution theorem. Therefore, Laplace of f of t star g of t is equal to Laplace of f, means e raised to at, and into Laplace of g, means e raised to bt. So which is same as 1 upon s minus a and 1 upon s minus b, which can be written as 1 upon s minus a into s minus b full stop. This is the answer. Second question. What is the discussion? Discussion is that you are given two functions convolution, Laplace is nothing but product of their separate Laplace, and therefore the star convolution is written in terms of multiplication, therefore separate Laplace, and then we can simplify this, get the answer. Second, if you are given these functions like this, sin 80 and say cos bt, then you have to write convolution theorem. Then you have to write this. Here we write sin 80 cos bt. Laplace of sin 80 is a upon s square plus b square multiplied by this cos. Laplace of cos is s upon s square plus b square. So we can simplify this as divided by two things, a square plus a square and a square plus b square, finish. This is what is the answer. Example number 3. Suppose you are given this f of t is equal to this one 1 by t, or say t square, and suppose this value is given to be cos 3t. We have to write this convolution theorem, then we have to write this is equal to, here we replace by t square because first function is t square and this is cos 3t. So what are the separate Laplace? It is 2 factorial divided by s raised to 3 multiplied by second Laplace, s divided by the cos, it's not cos, so s square minus 9. 2 factorial is 2, therefore we directly write 2. One s will cut and divided by s square into bracket s square minus 9. This is what is the Laplace of convolution. So we are looking convolution theorem examples. And last example, suppose you are asked to find out this, and this function is e raised to 2t into t square, and g of t is equal to, say, sin into bracket, say 2t. Okay. Here, let me consider this function different. T times sin 2t, like this, somewhat complicated. Then we have to find out these two things. So now this is somewhat difficult, therefore first we find out Laplace of f of t. First of all, we find Laplace of f of t is equal to Laplace of e raised to 2t into t square. Here we apply property, okay, by shifting property. We write Laplace of t square is 2 factorial divided by s cube, and here we replace this by s minus 2. So which is same as 2 divided by s minus 2 bracket cube. This is first Laplace. And then we try second. Laplace of g of t, that is the Laplace of t into sin 2t. Right? T into sin 2t. So which is equal to minus Laplace of sin 2t. Because we are multiplying by t, we are using property. So this is minus Laplace of this derivative, okay, d by ds. And therefore minus d by ds into bracket 2 divided by s square plus 4. So that is same as minus, now d by ds derivative is there, 2 is constant, we can take out, minus 1 upon s square plus 4 whole square multiply by twice s, minus minus plus 2 into 2 4, so it becomes 4s in numerator and s square plus 4 bracket square. So this is second Laplace. And third answer is Laplace of f t star gt is equal to product of these two. So this is first Laplace, 2 divided by s square plus s minus 2 bracket cube, and it is multiplied by 4s divided by s square plus 4 bracket square. Finish. This is what is the answer. You can simplify further. Okay, thank you.